Okay, let's evaluate the limit as x approaches 1 of a rational function 3x cubed plus 9x squared minus 14x plus 2 divided by 5x cubed plus 15x squared plus 8x minus 28. First, we plug in 1 for x in both numerator and denominator. Remember, this is a rational function. That's just a polynomial divided by another polynomial. In the numerator, we get 3 plus 9 minus 14 plus 2. That's 0. In the denominator, we get 5 plus 15 plus 8 minus 28. That also is 0. So this is an indeterminate form, 0 over 0. We have to factor out the source of 0 over 0 from each of the polynomial. That factor is x minus 1. That means x minus 1 will be a factor of both polynomials. It is not that easy to factor a polynomial, third degree polynomial. So one thing we can do is to use synthetic division, or I'm going to use long division. So x minus 1 goes here, and the polynomial from the numerator, 3x cubed plus 9x squared minus 14x plus 2 goes here. We're going to need 3x squared to multiply by x to reach to 3x cubed. 3x squared times minus 1 will be minus 3x squared. We subtract the second line from the first. 3x cubes cancel. 9x squared minus a minus 3x squared is 12x squared. And then we bring down minus 14x plus 2. Now the leading term is 12x squared. We're going to need 12x to reach it. 12x times x is 12x squared. And then 12x times minus 1 will be minus 12x. Once again, we subtract. And we end up with 12x squares canceling. Minus 14x minus a minus 12x is negative 2x plus 2. We're going to need minus 2 to reach negative 2x. Minus 2 times x is minus 2x. Minus 2 times minus 1 is plus 2. You can see when we subtract the second line from the first, we get a remainder of 0. So what that says is that polynomial in the numerator, 3x cubed plus 9x squared minus 14x plus 2 can be written as two factors. X minus 1 is what we need, and then 3x squared plus 12x minus 2. We are going to do exactly the same thing now for the polynomial in the denominator. We're going to take x minus 1, put it over here, and the polynomial from the denominator, 5x cubed plus 15x squared plus 8x minus 28 over here. We're going to need 5x squared to reach 5x cubed, so that's 5x cubed minus 5x squared. Subtract. Be careful when you're subtracting, because you may end up with a minus when you should have a plus and vice versa. Just keep track of that. 5x cubes cancel. 15x squared minus a minus 5x squared gives us a net of 20x squared plus 8x minus 28. So now we're going to need 20x. 20x times x is 20x squared minus 20x. Again, subtract. 20x squares cancel. 8x minus a minus 20x is positive 28x minus 28. And so if I add 28 right over here, I'm going to get 28x minus 28. They cancel out. We end up with a remainder of 0. Therefore, the polynomial 5x cubed plus 15x squared plus 8x minus 28 can be written as x minus 1 times 5x squared plus 20x plus 28. So let's revisit our limit. Our limit as x approaches 1 is now the numerator, instead of being 3x cubed plus 9x squared minus 14x plus 2, we can write it as x minus 1 times 3x squared plus 12x minus 2. The denominator, instead of being 5x cubed plus 15x squared plus 8x minus 28, we can write it as x minus 1 times 5x squared plus 20x plus 28. Here is the source of 0 over 0. Those x minus 1s, they cancel. We can now safely plug in 1 for x and what's left. In the numerator, we get 3 plus 12 is 15, minus 2 is 13. In the denominator, we get 5 and 20, which is 25, and then plus 28, that comes out to be 53. So the answer is the limit of the original problem is 13 divided by 53. For more